Okay, so we're going to cover keys and addresses today. I think it's important to understand these. Even though we didn't invent any of these at Xcash, I think it's important to understand these when you're using Xcash, especially since we have the public and private transactions. These will work a little bit differently. Okay, so let's start with the keys. So we have a public address. So that's the address you give people when you want to have them send you Xcash. That starts with an XCA address. Then we have the spend key. Whoever knows that key is basically able to spend funds from the wallet. The view key is basically whoever knows that key is able to actually decode all of your private transactions. So it's more of a legacy type key because there's different proofs now that can decode one transaction instead of all the transactions. And then we also have public transactions so that you don't have to have some transactions decoded. And then the seed words are basically 25 words, and they're a combination of the public address, the view key, and the spend key. And it's just an easier way to import a wallet, essentially, is what they're used for. Because there's two ways in the wallet you can import or you can restore from keys, and you'd have to type in your public address, your view key, and your spend key. Or you can just restore from deterministic wallet, and all you have to do is provide the 25 words, and it can calculate the public address, the view key, and the spend key from the 25 words. So essentially, it's just a compact version of the three combined. So basically, the only one you actually want to share is the public address. You want to keep the other three to yourself. Now, even the public address doesn't actually ever need to be shared technically. And we're going to talk about that on the next part, the addresses. So there's addresses that start with an XCA, an XCB, or an 8. The XCA we already talked about. That's the public address you give people when you want them to send you Xcash. The XCB, so let's talk about payment IDs. So payment IDs are basically just data that's sent with the transaction, so you can know who paid you. So essentially, at first there was just a regular, it's called long style payment ID. It's 64 hexadecimal characters. And what that does is it allows you to identify who paid you because this is a private blockchain. And a good example of this is let's say you have three people. They all need to pay you $5 in Xcash. So let's say you tell them, okay, today pay me the $5. So then you get two transactions for $5 in Xcash, but you don't get the third one. Then you ask all three people, did you pay me? And they say, yes, I paid you the $5 in Xcash. So how would you be able to tell which one didn't pay you? So that's an issue with a completely private blockchain. Now, obviously, you could use in Xcash situation, you could use public transactions. You can tell people, hey, send me. Don't send me a private transaction. Just send me a public transaction, and then you could be able to see which address didn't send it. But if you wanted, or if you can't force them to send you a public transaction, obviously, so you can give them each a different payment ID, and then basically you would know. If you give someone 64 zeros, you give the other person 64 ones, you give the other person 64 twos, and then it will show you in your wallet, like, the zeros and the ones sent you the Xcash, but the twos didn't, and then you would know, okay, that's the person I gave The 2 he didn't pay. Eventually, it was changed from 64 characters to 16 characters, and also encrypted. It was a little bit shortened, and it was encrypted because there was privacy concerns with the actual data just being in the transaction. So this is where an XCB address comes in. So an XCB address uses the newer 16 character encrypted payment ID, and that's all it is. An XCB address is a wrapper essentially for the XCA address and the payment IDs. So literally, if you want to like write an equation, XCB would equal XCA plus encrypted payment ID. So the reason for combining the XCA and the encrypted payment ID into a new, it's not an address, but just a new format, is because a lot of exchanges use, they need to know who sent them the funds. So then people started figuring out that if you forget to type in the payment ID when you send it to an exchange, they're not going to be able to know who actually sent those funds. So the XCB was created that way. If an exchange has an XCB, it's a lot easier to just send them the Xcash, and it won't give you the chance to forget to include the payment ID because the payment ID is included. XCB addresses, one note on this, are not actually real addresses, which is why I called them like a wrapper, an equation of XCA plus encrypted payment ID equals XCB. If you send a public transaction to an XCB, you can find that it converts it to the XCA plus the payment ID. So now the last type of addresses are the ones that start with an 8. These are called subaddresses. So eventually it was realized that maybe it's even more private if we don't even have to ever give anyone our real XCA address. And we can just give them a different address. So these are called subaddresses, and subaddress is basically just think of it as, it's not a throwaway address, but think of it as a throwaway address where essentially, go back to the example where we have to pay, or 3 people have to pay us. In this case, it makes it much more private to say, okay, I generate 3 subaddresses. I give each person a different subaddress, and then they send me the Xcash. I'm still able to tell who did or who did not send me the Xcash because of the different subaddresses. But the added benefit of using this is no one ever had to or needed to know my XCA address. So my real address is hidden, and I'm still receiving funds from people. So the privacy on this really works well for Xcash in particular because, you weren't able to basically figure out anything really from an XCA address on a completely private CryptoNote blockchain. But with public transactions, you can see the public transactions, obviously, of an XCA address. So this works out well because if you give, and this is a real address, if you send a public transaction to a sub address, it will actually show the sub address. So this works out really well for privacy on Xcash in particular because you can keep your XCA address free of any public transactions. And then if you want to receive public transactions, you can just give people the sub address, and then each sub address, if you give 3 people 3 different sub addresses, then basically if you, basically every sub address will show only one public transaction to it. And these are derived from your spend key and view key. So they're mathematically linked to your XDA address, but they're not you're not able to work backwards to figure out. It's kind of like a hash. Like you can't work backwards to get the data out of the hash. That's not how it works, but it's like that to where you can't work backwards to get the XCA address from the sub address. So that's it for this video. Hopefully everyone finds it useful. Because it explains basically the CryptoNote protocol of keys and addresses, but it explains it more importantly how they work with Xcash, how they work with the public and private transactions. So thank you for watching.